Hey. The topic I am going to discuss is parametric and non-parametric tests. Parametric and non-parametric tests. These are two different methods of statistical tests used to compare data from two or more groups in hypothesis testing. The main difference between them is the assumptions made about the distribution of the data being analyzed. Parametric tests. Parametric tests are statistical tests that make certain assumptions about the population distribution from which the sample data is drawn. These assumptions include: 1. The data is normally distributed. 2. The variance of the data should be same across different groups or samples. 3. The data should be independent of each other. Examples of parametric tests are: student's t-test, paired and unpaired, analysis of variance, ANOVA, etc. Parametric tests use a test statistic, such as a t-statistic or an f-statistic, to determine if there is a significant difference between groups or a significant relationship between variables. This test statistic is compared to a critical value to make this determination. Non-parametric tests. Non-parametric tests do not make any assumptions about the underlying distribution of the data, and they are often used when the data is not normally distributed or when there are outliers in the data. Examples of non-parametric tests are Wilcox-Signed rank test, Mann-Whitney U-test, Kruskal-Wallis test, etc. Non-parametric tests use various methods, such as comparing ranks, medians, or the number of observations above or below a certain threshold, to compare groups or test for a relationship between variables. Both parametric and non-parametric tests use a critical value or a p-value to interpret their results. If the test statistic is higher than the critical value or the p-value is below 0.05, then the null hypothesis is rejected, indicating that there is a significant difference or relationship between the groups or variables. On the other hand, if the test statistic is lower than the critical value or the p-value is greater than 0.05, then the null hypothesis is not rejected, indicating that there is no significant difference or relationship. Advantages and disadvantages of parametric and non-parametric tests. Advantages of parametric tests. Greater statistical power. Parametric tests are generally more powerful than non-parametric tests when the data meet the assumptions of normality and equality of variance. More precise estimates. Because parametric tests make assumptions about the underlying distribution of the data, they can provide more precise estimates of parameters such as mean and variance. Wide availability. Parametric tests are widely available and have been extensively studied in statistical literature. Disadvantages of parametric tests. Sensitive to outliers. Parametric tests can be sensitive to outliers, which can skew the results and lead to incorrect conclusions. Assumptions. Parametric tests require the data to be normally distributed and have equality of variance. Violations of these assumptions can lead to incorrect results. Needs large sample size. Parametric tests are more reliable with larger sample sizes. In some cases, the sample size may not be large enough to meet the assumptions, which can lead to inaccurate results. Advantages of non-parametric tests. Robustness. Non-parametric tests are more robust to violations of assumptions. They can be used when the data is non-normal or the variance is not equal. No distributional assumptions. Non-parametric tests do not make any assumptions about the underlying distribution of the data. Can be used with small sample sizes. Non-parametric tests can be used with small sample sizes, which can be a limitation of parametric tests. Disadvantages of non-parametric tests. Lower statistical power. Non-parametric tests generally have lower statistical power than parametric tests. Less precise estimates. Because non-parametric tests do not make assumptions about the underlying distribution of the data, they may provide less precise estimates of parameters. Lack of resources. Non-parametric tests are less commonly used than parametric tests in many fields, which can limit the availability of resources and support for learning and applying these tests. Difference between parametric and non-parametric tests. In parametric tests, assumptions are normally distributed data, equal variances, Independent data. In non-parametric tests, no assumptions about the underlying distribution. In parametric tests, data types are continuous, normally distributed. In non-parametric tests, data types are continuous, ordinal, or non-normally distributed. In parametric tests, sample size should be large. And in non-parametric tests it is small. Test statistics in parametric tests are mean, variance, t-value, and f-value. And in non-parametric tests, median, rank and u-value. Power in parametric tests are high, and in non-parametric tests are low. Sensitivity. Parametric tests are sensitive to outliers and extreme values. Non-parametric tests are robust to outliers and extreme values. Complexity. Parametric tests are often more complex to calculate and require more assumptions. Non-parametric tests are generally simpler to calculate and require fewer assumptions. Thank you for watching. If you found this video helpful, please give us a like. Subscribe for more videos and also share with all your pharma mates. Thank you.